Record to the cloud. So number 6, a clothing store marks up the price of a shirt from $20 to $33 and a jacket from $60 to $93. The markup policy of the store for items that that cost over $10 is assumed to be linear. All right. So what we're going to do is write a linear function that expresses retail price in terms of cost C. That's kind of like, I mean, it's part A, but it's sort of like step 2. Let's look at step 1 here, which is write a linear equation, period. You know, whether it says in terms of C and R's and all that stuff, it's a different story. Let's just get something that we can work with in terms of X and Y. And then from there, we'll modify it so that it fits the criteria of the problem. All right. So what I'm going to do, I'm actually going to show you some tricks of the trade here, but we'll start off in the most basic sense first, and that is saying that 20 gives a value of 33. All right, that's the markup. 20 goes to 33, and 60 goes to 93. All right. These are ordered pairs. One is an input variable, the other is an output variable. All right. They mark up the price of a shirt from $20 to $33. So if one causes the other to happen, it has to be valued at $20 first in order to be marked up to 33. The jacket has to be valued at 60 in order to be marked up to 93. All right. So these would be our X and Y variables. All right. So if we want to do this by hand, and to some extent we do, but we also want to learn how to do it on the technology, we want to find the slope. M is going to be equal to change in Y over change in X. The Y values are 93 and 33. So 93 minus 33. The X values are 60 and 20. As long as you subtract them in the same direction, you're good. So I subtracted 93 minus 33. So I just got to make sure I do the same thing for the X's, and I won't end up with any kind of contradiction. So 60 minus 20. And you could do that by hand in your head, whatever, or you can do it on the calculator. So I'm just going to pop it into the calculator, and we'll say M for slope is equal to the fraction 93 minus 33 over 60 minus 20. And it gives us a 1.5. Now, it's a slope. So if you felt the need to graph this by hand, you'd probably want your slope in fraction form, but a decimal form is fine too. So this is the same as saying 1.5, but if you want it in fraction form, you can hit the little fraction icon, you'll get 3 over 2. All right, so either way. So from there, we need to write the equation of the line. So the point slope form, talked about this a bunch over the last couple of classes, point slope form y equals m times x minus x sub 1 plus y sub 1. We know the m. We just need an x with a subscript of 1, an x sub 1, and a y sub 1. Okay? We could choose either of these two coordinates. Doesn't matter which one we go with. All right. So I'm going to choose the first one just because, well, that's my answer, just because. All right, so this will be my x1, my x sub 1, and this will be my y sub 1. So I'm going to pop in the slope, 3 over 2, leave the x and y's, minus the x sub 1 value, which is 20, plus the y sub 1 value, which is 33. And that would be my equation, if we're doing it by hand. All right. So I could get that all into Desmos and go that route, you know, like I just type it in if I want. But there is a technique on Desmos that'll allow you to come up with the equation without really doing any of this kind of work, right? So it's kind of nice. I'll show you that in a second, right? But we do need to convert it over into the proper notation. So normally a function would be solved for y in terms of x. Here we're doing r in terms of c. So r is going to take on the value of y, and c is going to take on the value of x. All right. So we have an equation. Good looking equation. Gets the job done. But what I'm going to do, like I said, is I'm going to show you how to do it on Desmos so that it'll give you the entire equation without you having to do any algebra.
Professor, what made us put R and C where they are?
Because y is normally written as a function of x or in terms of x. Here they're telling us to write r as a function of cost. So r takes on the role of y, meaning anywhere where there's a y, we replace it with an r. And cost is taking on the role of x. So anywhere there's an x, we would replace it with, I meant to say c. C takes on the role of x. So everywhere that there is an x, we would replace it with a c. All right, because remember, there's always that input-output relationship. Whatever the input variable is, that's x. The output variable is the y. So here, cost drives the retail price. Right? However much the store pays to purchase the item, that will impact how much they then turn around and sell it for. That would be the retail. So this is a very heavy duty Desmos kind of approach, but it's pretty user friendly once you get the hang of it. All right. And unfortunately, or fortunately, depending on how you look at things, when it comes to Desmos, that's kind of the name of the game, where it's like, once you get the hang of it, right, once you learn how to use Desmos, it gets a lot easier. All right, so what we're going to do, and I'll just kind of run you through the process here. We start off by creating a table. So I hit that little plus sign, and then I input table. All right. So in that table, the first row of information will be my first ordered pair, my first coordinate. All right, so I'm going to type in 2033. All right, that's one coordinate. The second one is the 6093. So I'm going to tap down or hit enter and type in 6093. All right. Now, at first glance, that didn't really accomplish anything. You're looking at the graph. I don't see anything. But that's because these numbers are outside of the domain. So I'm going to pinch zoom out. You see that first coordinate there, 2033. Pinch zoom out further, and you see the second one. All right. Now, one thing you can do is, I mean, we did all the algebra. You could just type in your equation here and see if it goes through those 2 points. That would be a good way to check your work. But we want to keep our eye on the prize here. What I want is a way that will do the work for me. All right. So before I go too far, I'm going to save this, and we're going to say writing the equation of a line. And that'll go up on Blackboard when we're done with class. All right. So this will be our example. Now, the command is actually fairly simple, I guess. There are a couple of differences between what we would write on paper and what we would put in Desmos. All right. So this is our point slope form. So copy, paste. So this is our point slope form. In Desmos, we'd actually type in almost exactly the same thing, except you'll notice in the table, it's not X and Y, it's X1 and Y1. So what I would actually do here is, and this kind of gets, it's a little weird because we already have an X1, Y1. What we're gonna write is Y1 tilde M X minus H, sorry, there should be an X1 plus K. All right, in Desmos, that's what we would type. You see it has the same structure. Like all the bits and pieces are in the same place. We're just using different variables. All right. By typing this in, Desmos will actually give you these three coefficients, this one, and this one. And you'll have the equation of the line. So let me show you. So we're going to tap Y1. Then I'm going to go into the keyboard. If you're not using if you're using a touchscreen, then you need to do it this way. If you're not using a touchscreen, then you just find the tilde key, which is Shift, and the key that's right next to the one on the left. All right. So if you're using a regular keyboard, but here the tilde is two boxes or two keys next to the enter key. All right. I'm going to type in an M, open paren, X1 minus H, close it up, plus K. All right. Now, it doesn't seem like it really did anything for us, but it actually did everything we needed it to do. All right. So it created a model that will pass through these points, the relevant points. It's just going to look a little different, but that's okay. All right. As long as what comes up on the screen looks like it should look, which is to say that it passes through the 2 points that we plotted. This one, if it'll take it, this one here, and this one here, then you know that you have the right equation, or a version of the correct equation. So I'm just going to zoom a little bit better here. All right. So what this is telling me in Desmos, and I'll do a quick screen grab. It's telling me that if we use this form, the M, H, and K values should be these numbers, these parameters. All right. So let me just paste that in and I'll show you. Screenshot, put it. All right. So it's telling me that I should be looking at a Y1 tilde, the M is 1.5, X1 minus 1 plus 4.5. But that's in Desmos language. In real language, in real language of mathematics, that would be Y equals 1.5 X minus 1 plus 4.5. Now you might look at that and say, but wait a minute, we did it by hand and we got something different. We got this equation here by hand, and on the calculator, we got this equation. What I can tell you is, if you simplify this equation here and simplify this equation here, they'll both simplify to the same thing. All right, they just look a little different right now, but they are the same. All right, so then I could write this as R of C. Oh, well, actually, we're not using that notation. R equals 1.5. Instead of the X, we use C minus 1 plus 4.5. All right, so that's definitely a more tech-based approach, but it gets the job done. And it doesn't involve any algebra. But I would understand if there are people in this class right now that are looking at it being like, yeah, can I just do it with the algebra? I prefer that. Yeah, absolutely. But I can tell you, yeah. But when you get to the when we get to the more complicated equations, polynomials, logs, and exponential functions, the only thing I'm going to ask you to do is just keep an open mind. Because once we get to those topics, you might say, all right, I like the algebra for the lines, but for this stuff, I want something to do the work for me. All right, I see a question floating around there. Yeah.
Do you care which one we use? Like, say
I
on
do
the
not.
exam thing? So
Either one is fine.
because obviously we can't show work for that. So if we just put that down, you would know that we use Desmos.
Well, that's the thing. You can show work. All you have to do is create a share link and copy that share link right into your submission for Blackboard.
Oh, okay. Thank you.
Yeah. So, but if it's a multiple choice question, it wouldn't even matter either way. But yeah, if you do work on Desmos, you can always submit the Desmos work, right? So it's just an avenue for you to pursue if you're interested, right? But let me show you real quick. I'm going to turn this equation off. I'm going to put in the one we came up with by hand, y equals 3/2 paren x minus 20, close it up, plus 33. All right, so that one fits. It goes right through the two lines. And then I'll put the one we came up with Desmos. Well, I mean, we already know it's going to work, but I'll write it as 1.5 x minus 1. Oh, that's not a 1. There it is. Plus 4.5. And you see that they actually give the same line. All right, you can toggle them both on and off, you know, one at a time and make sure, but they do give you the same thing. Oops. And so what I like to do, just for my own sake, if it actually lets me, is I like to make one of them either dashed or just maybe a little bit thicker so it stands out, and then turn them on simultaneously. It just gives it a more appealing look, but it makes me feel like, okay, I definitely got this right, you know? But yeah, a couple of options. And I'm always going to give you, I mean, we've talked about this before, I'm always going to give you the by hand and the Desmos approach, or the calculator approach, and let you decide which one you want to go with. And I mentioned this one before. This course does not have the term algebra in the title, right? So we're not looking to get bogged down with algebra. You can, if you choose to, not the part where you get bogged down, but the part where you use algebra, you can go ahead and do that, but it's never going to be a requirement. There's always going to be a tech way of doing everything that we're going to talk about.
Professor, right? In order to get y equals 3/2, that equation simplified, how would you do that by hand? Like, or is there a way that we could do it on the TI calculator?
So if we're going to simplify it, what you would do is distribute.
Okay.
And so that would give you a 15, I think, if I'm not mistaken. Actually, it can't be 15. Let's see, 30. Yeah, 30 plus 33. Just double checking. Yeah, 3/2 is 30. And then simplify by adding them. And that would be plus 3. Now, as opposed to the other one, where, and I'll shrink this down and put it all together. If I simplify the other one,
I was assuming that they were going to match 3/2x plus 3. It was going to match 1.5. Or are they going to match?
they will. They will.
Oh, they will.
Yeah, because you're going to get 1.5x minus 1.5 plus the 4.5.
Okay.
The negative 1.5 plus the 4.5, that's going to give you a 3. So the 1.5 is the same as 3/2.
It's 3/2, right? Okay.
And so they are equivalent.
Oh, that's interesting. Okay. All right, cool. It just, when I looked at it, it was like, how could we get there?
Yeah, it's weird to think that it, like all roads lead to Rome, that it's going to work out, but it does.
Thank you.
Barring, you know, the odd mistake everyone's making. and oh, actually, I don't need this. No. Then bring this back. Bring this back. And now it'll, so draw a little line here and move that line over, kind of. And there you go. All right. So now we answer the follow-up questions. What does the store pay? So that's a cost value. All right. The interpretation part of it is important because you got to know what the question's asking you. What does the store pay? So that's C, for a suit that retails for $240. I highlighted the wrong thing. Go blue, retails, that's R. So they're saying here, what is C if R is equal to 240? Oh, capital R. I realized that belatedly. All right. So what we need to do is one of two things. Solve the equation algebraically. So if you're algebra minded, you would take this equation here, or the Desmos version of it, but odds are if you want to do this step algebraically, you probably didn't do any of this stuff. All right. Set it equal to 240. And solve for the value of C. All right. So we're going to do that with little distributive property, you know, all that jazz. So algebra. All right. So I'm going to bring it in. I'm going to distribute. So 3/2 C minus 30 plus 33. We kind of already did this, but that's all right. Combine our like terms. That's where the 3 comes from. Then we would go ahead and solve for C by subtracting the 3 from both sides. Continue it on here. So we would get 237 is equal to 3/2C. Then either divide both sides by 3/2 or multiply both sides by 2/3. And you'll get the value for cost. And I'll just crunch it out here. So 237 divided by 3/2. I mean, you can put that as a decimal if you want. I'll just put it in parens. Actually, I don't even really need the parens, but whatever. It's 158. All right. So the store would pay $158 for the item it's going to turn around and sell for $240. And you're like, oh, those terrible people. But they're in business. So what do they, what do they get out of it? They get a handling cost and all that good stuff. All right. So that's one way. Another way, again, the more Desmos related approach would be still, you would set up your equation. So let me take this equation here. All right. We would put it into the calculator using X instead of C. So I'll make that an X. But we're going to put it in separately. We're going to put it in as 2 separate equations. All right. So one side would be one equation. So we'd write it as y equals 240. All right. So the left side gets written as one equation set equal to y. The right-hand side would be written as a separate equation, also set equal to y. So we take the left-hand side, put it in as one equation. take the right-hand side, put it in as one equation. So this is in Desmos. All right. So I'll shrink this down and get it up in here in a couple of minutes. But we already actually have one of them written in there, so we're good there. It's right here. All right. I'll make that a solid line again. So I would type in y equals 240. I'm just going to juxtapose them a little bit. All right. Then find the intersection. All right. So we have two lines here. They're going to cross each other. Doesn't look like they cross each other, but if I pinch zoom out, you see that they do in fact cross each other. All right. That 240 told me I needed to go up a little bit more. All right. Find where they intersect. It's no more challenging than just tapping onto what you think the intersection point is. You see a gray dot up here indicating that that Desmos can tell you an intersection point. Tap on it again, and it'll tell you what that intersection point is. All right. So that intersection point is 158, 240. We already knew the 240 part. We typed that in ourselves. It was the 158 that we were looking for. So that 158 would be the value of x, but in this context, it really amounts to a value of c that would satisfy this equation. All right. So that's going to be the same value that we came up with over here. All right. The same value. So you can get your solution that way. So now I just got to shrink a lot of this stuff down and get it to fit. All right. So again, if you want to solve an equation, you just put in the left side of the equation as y equals, the right-hand side of the equation as y equals, and then solve. I'll show you another example in a sec, just because this is a pretty important concept. But I wanted to save this Desmos so that we can have it, you know, you can use it later when you're writing the equation of a line, because all you would have to do is replace your ordered pairs here, the 2033 and the 6093. All right, if you do that, it would spit out the slope, the equation in the appropriate form. You just got to pop the numbers in. All right, so I'm just going to modify it just a little bit to get it set up for next time, but it really is just a matter of really just following these steps where you just plug it in here and then just go with what you have here. So I'm just getting rid of that extra fluff. I'll turn this on, I'll save it, and I'll tweak it a little bit more later. But I want you to be able to access that on Blackboard, so when it comes time to take the test, you're in good shape. All right, but let me show you another example where you're solving an equation. All right, just a quick side example. So let's say for example, they're asking you to solve. So I'll keep it simple, like 20 equals, let's say 3 times e raised to the x power. Maybe that's not that simple. I'll just say 3 to the x power raised to the x. The little caret symbol indicates that it's raised. All right. So simple looking equation, but not linear. You know, so a lot of funny business going on with this. All right. You got a 3 to the x power. That would actually, we're not there yet, but that would actually involve a logarithm. All right. So what you do is you take the left-hand side of that equation. There's two sides. You got the equal sign splitting between the left and the right. The left side is the 20. So you write y equals 20. Then the right-hand side, to the right of the equal sign, 3 to the x, we're going to write y equals 3 raised to the x power. All right. If you want to find a solution, you pinch zoom until you find an intersection, a clean intersection. Tap on that intersection, a gray dot will appear. I mean, another gray dot appears too. It'll show the y-intercepts and x-intercepts and all that stuff. But the one that we care about is where the two graphs cross. That gray dot, tap on it a second time, and it'll tell us the solution to the equation. All right. You can solve any function-related equation that way. So if you think back to college algebra trig, maybe you struggled with solving trig equations. This is your way out of that. All right. Exponential functions can be tricky. Log functions can be tricky, but all you're really doing is writing y equals whatever the left side of the equation is, writing y equals whatever the right-hand side of the equation is, and then just zoom until you find an intersection, and then just tap on that intersection point. All right. On the TI, it's a little bit more complicated, but I'll go over that in a minute. I want to do all the Desmos stuff first, and I'll do the TI. All right. So we have equations. We got equations all over the place. But now we can answer all the follow-up stuff. What is the practical domain of this retail function? Well, you look at this right in the blurb in the beginning. I'm going to go green for those keeping score at home. For items that cost over $10. All right, so they're giving us a natural low bound. They're telling us that we only care about this equation, this linear equation, for items that are over $10 in value. All right, so the domain, in this case, the practical domain, is going to start off with a value of 10 with parentheses because it's got to be over 10. It's not going to include $10. All right, so $10.01 is fine, but $10 even, no good. All right, but then we need some reasonably large value on the high side. All right, so the answers are going to vary there. You have a lot of different possibilities. I mean, you really won't be wrong if you put something that's like I said, reasonable, stable. That's wonderful. You know, this is good bad 1,000 today. But whatever you put that's reasonably large, it's going to be fine. You put 100. I mean, you probably should put more than 158 because we just showed that a possible value. Just remember, it's a clothing store. Right? So it marks up a price of a shirt from $20 to $33. So what they're saying is that they charge around $33 for a shirt, and a jacket they charge around $93. So we're not talking about, you know, like something on Fifth Avenue. You know, like we're talking about something that's, you know, like I don't want to say budget clothing, but it's something like in a reasonably priced realm. So maybe like Target. You know, so you probably wouldn't say a domain from 10 to 100,000. You know, now if you're going to like a high-end boutique kind of place, then maybe it could be that expensive. But as long as you put something that's reasonably large, you're fine. All right. Explain what the slope of the linear function means. Now remember, the slope is a rate of change. It's y in terms of x, but in this case, it's retail price in terms of cost. So normally the slope would be change in y over change in x. In this case, it's the change in R per change in C. All right, so it would be written as, now the slope itself is 3.5, 3/2, which is 1.5. So we would be saying that the rate of change of retail, which is dependent on the change in cost, can be written as, so there is a change of, well, it's money, so we could say $1.50, $1.5, $1.50 in retail price per unit of cost. But to be more specific, that change, it's a positive change. So this change would be an increase, because the slope is positive. And per unit of cost, we can get even more specific with that. That unit of cost is money, which is measured in dollars. So per $1 of cost. All right. So really, I mean, you could say there's a change of $1.50 in retail price per unit of cost. But if you want to be more specific, contextually, you could say that there's an increase of $1.50 in retail price per $1 of cost. All right. Now, sketching the graph and indicating the window used, I had mentioned before, as in last class, that's just a matter of snagging the graph from Desmos, putting some labels on it, and calling it a day. All right. So the y-axis is cost. I'm sorry, the x-axis is cost. The y-axis is retail. And you know, any kind of reasonable labels are going to be fine. I mean, you want to put the units, that's fine too, but this is good enough. As long as you can see the important features of the graph, you have everything that you need. All right. So the points that you needed to plot, and also any x or y intercepts. All right. So I would take this graph, plop it right in, or create a share link on Desmos and plop that right into Blackboard and be done with it.
I'm not really certain how you got $1.50.
$1.50 was the slope.
Oh, it's the
Yeah.
slope. Thank you. Thank you.
No problem. All right, and so there's your graph, and there it is.